Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. Today on my bench I have a combo. I like to call them duets because I think of them as a duet. These is a pair of Pioneer amplifier tuner. This is a TX-480L and an TX-408L, SA-408. So they came as a combo. This is a client dropped this off. He wants me to do some work on it. And this thing has a kind of a special history to it because this was originally purchased in Ireland. This came from Dublin, and a lady that came to Canada brought this with her. I don't know if it was much good to her once she got it here, but she liked it and she hung on to it and she brought it with her. So yeah, it has, somebody has hacked off the original 220 power cord end and put this on, and somebody, like, look at this, it's got the original power cord. So part of the conversation with my client is maybe I can do a conversion on this for the power transformers. I probably could do the power amplifier. I can salvage a transformer out of something similar size, capacity, and sub it in there, and then it'll be 120 volts. The tuner shouldn't be a problem. Like I'm looking at the back here, it says AC 220, 240 volts, 50, 60 hertz, 8 watts. So it shouldn't be hard to get like a 10 watt transformer and sub that. And this one here, 190 watts, so a 200 watt transformer. Very little information on this outside of a few pictures I found on the internet. I can't find any service information. I don't know anything about it. This kind of stuff we never see in North America. This is unusual, to say the least. So yeah, I want to do conversion on both of these and try and get them going. He never told me what was wrong with them, and I think there is a problem, but he supplied me with this thing here. This is sorry, I'll crank this up, voltage converter, and we can use this to test and work on the two units. So that's good. So let's tie into this. Let's hook it all up and see what it does or doesn't do. All right, I'm all plugged in, hooked up, ready to go. So let's power this thing on. All right, that seems to be working. Hit the power button. I don't hear any clicks. Speakers A. Okay, we got a scratchy pot. Phono. I'm getting audio on both channels, which is good. Getting hiss. Let's turn the tuner on. This tuner is kind of cool because it has long wave. That's something we don't see here. Long wave, medium wave. This is AM right now. This is FM. What happened to my left channel? Oh, it's just dirty pots. Okay. Let's get an antenna here and see what we can pick up. It seems to be all working. I'll just connect it to the 300. I don't think the meter is working at all. I'm not picking up stereo either. So the tuner looks like it needs some work. It's having a trouble picking up anything. Only got it. Yeah, the tuner's having a lot of trouble picking up stations. Meter's not working. No FM stereo yet that I can. If it breaks through the muting, it still doesn't give me stereo. Probably it needs a good alignment. Okay, so we got dirty pots, dirty switches. Seems like both amplifiers are working, but I've been fooled by that before. So let me hook up a source and we'll put some power through this and we'll see what kind of a signal it is. Okay, just trying out the tuner here. Got a lot of dirty switches. It's really, these switches didn't want to work to begin with, but after you work them a few times they start. So I got an AM long wave and it is picking something up and the tuning meter is working now, but there's nothing here without a long wire antenna. I'm not going to pick anything up in Canada. We don't use long wave. Medium wave is silent, but if I play with the switch, I can get it to work. It's just a dirty switch.
With Judy Aldis.
Okay, now if I go to the bottom of the band, something interesting happens here. It breaks into an oscillation. There's definitely something going on with the AM tuner. It's kind of... The AM is working though. It's just like dirty switches and... got that weird oscillation. Okay, so I have a good start, a good idea what to do with the tuner, good idea what to do with the amplifier. The amplifier is working. It's just that the left channel will continuously drop out for no reason, and then you have to give it a kick of power. Let's see here. Got my tone hooked up. And here everything's badly scratchy. Dirty switches. So I'm going to need to know, for part of the conversion, I'm going to need to know what voltage it's running at right now. So let's see if I can measure this, if it'll let me. Maybe my probes won't go in deep enough. Might have to take the lid off and do this. I'm not getting anything here. There we go, 234. So we got 234 volts. Okay, I'll have to record that number because that's going to be important for doing my calculations on power transformers. So when I measure the secondary on the inside, I need to know the voltage coming in for the primary. All right, Okay, here's the power supply for the tuner. Power comes in 240 volts or 220 depending on what area you're from. It's primary. Secondary has 3 wires. One's a common, and then there's 2 taps. One tap is for 220 volts, one tap is for 240 volts. And depending on which one you want to use, you place the fuse in the fuse holder. And then the power switch, this is the power wire going to the tuner itself. So you should have AC voltage here on between the black wire and the red wire. Let's see what we got. And we got about 8.4 volts. It seems low. Let me shut this off. Actually, let's measure. Oh, maybe I'm measuring the wrong wire here. Hang on. No, it's still 8.4. So this one here measures around 8.5. This one measures even lower, 7.6 volts. So I'm going to need about a 9-volt transformer. And since this thing consumes, it says it consumes 8 watts, I'll probably need one that's about 10 volt amps or so. It's not a very beefy transformer. It's pretty easy to find something like this, small like this, at 9 volts, at 120 volts input. So yeah, we'll go with that. We'll go with the 8.5 9-volt input. So look for a 9-volt transformer. Here's a look at the rest of the tuner. It has a lamp behind the dial pointer, which kind of illuminates the front area here, but I'm looking at this and I'm kind of concerned because that lamp is right up against the dial string, and that dial string is kind of turning brown, almost black. I'm scared it might break. So what I might do is take this lamp out and put an LED in there. It'll be brighter and it will run a lot cooler. Here's the rest of the tuner. Not much going on here. Nice sized bar antenna. This is for the long wave, and this is for medium wave. Lots of coil wraps for long wave. It's lower frequency. Pioneer chips, HA-1138. That's and PA 3001. Looks like a nice little tuner. We have something here that's burned out lamp. Is that what that is? Oh, that'd be the stereo indicator, I think. And then there's the meter. But there's no other lighting other than that. So it's just the one lamp. Yeah, the stereo indicator might be burned out. Looks like an incandescent bulb too. So, interesting. It only runs off about 9 volts, eh? Another thing I might consider is changing this out to an F connector. That's pretty much useless in this country. We have no connectors that fits that. So I'll see if I have a chassis mount F connector. If not, I can get one. They're pretty easy, cheap to get. Alright, let's have a look at the power amplifier. Integrated amplifier. Looks pretty clean. Quite a bit of grime in here. It's almost like a greasy grime. I might have to take this out. But compressed air won't touch this. I might have to scrub it with something. So we got a couple little tiny little 4700 to 35 volt caps. It's our input power transformer, and we have only, well, this side here, this is all our input voltage, mains, power switch, fuse. Be careful, nothing's really insulated here. And this is our secondary. We've got a center tapped. So let's turn this on and measure our voltage on our secondary. Nice thing about this amplifier is it's all discrete transistor, so I think it's worth saving. If it was a power chip one, I would kind of go, nah. Okay, so let's see what we got here for voltage on the secondary. 46.8. So half of that would be 23.72. 46.8. Okay, I'll write that number down. Shut that off. Yeah, it's got like a film of grease or something. Everything's coated. Like it was in a kitchen maybe? Alright, so does it have a removable bottom? Yes, it does. How about that? I'm going to pull the bottom off, have a look underneath. Alright, so here's the bottom removed. I can see some cracked solder joints already. There's some up here on the input connectors. And speaker connectors don't look very good either. But yeah, I think this would benefit from a resolder job. Looks like we got a lot of cracked solders here and there. It's going to have to give it a good looking over. But it looks very clean underneath. Okay, so let's go about finding a transformer for this thing. Alright, so I went through all my power transformers I salvaged from other pieces of equipment. And all of these are too high. 54 volts, 70 volts, no, 57 volts, 61 volts, 70 volts. This is the only one that was at the right voltage, 45.5 volts, but it's not center tapped. So I was like, what the hell? So this is my last ditch effort. I got my Harman Kardon HK350i. This was the parts unit I picked up off eBay. So I got it plugged in. I'm going to test this one here. I think this one might be close. Let's see here. This side, well, you can't even see the voltmeter. Let's try that. This side here is 14. That's for the lamps, I believe. The green wires. Yeah, that's close. Okay, the blue wires is for the power amplifier. We got 46.2. That's perfect. This is the right voltage. So I'm going to yank this transformer. Actually, you know what? It's not the right voltage. It's actually a little bit high. Because I checked the nameplate of the Pioneer and it says input 220 volts. But when I took my measurement, I was feeding it 234, which is probably about 6% too high. And I measured 46.8 volts on the windings, and it should be down around 44.5. But this will work. This will work perfectly. 46. That's 2 volts too high. So what? It'll work. So I'll yank this transformer and put it in the Pioneer. Okay, so I'm just starting to put the transformer back in, but everything's covered with this greasy film and dust. I think I'm just going to take this outside and blow it out with compressed air and probably hit it with some brake cleaner just to get rid of all that oily, I don't know what it is, but it's on everything. So hopefully that'll clean it up. I don't think alcohol will touch it. I sprayed it a bit down here with some flux remover, and it kind of cleaned it up, but you know, that stuff's like $15–20 a can. I'm not going to empty a can of flux remover on an amplifier. I'll just use brake cleaner. It's cheap. So as part of the conversion, I removed the European outlets on the back, and I made a blanking plate out of steel and bolted it on and cut a hole just big enough for a North American outlet. So this will be our AC outlets, courtesy outlets, and I'm ready to put this back on now. Transformers installed, and then I just need to get the power cord put on, and I can wire up all the primary. It's all ready to go, and then with the rest of it, just a matter of assembly. I took out the main board because it's a lot easier to work on when it's out, and I wanted to clean and inspect this, all of this, because I had found some cracked solders on the bottom, so I'm going to make sure that's all good. Clean all the pots and switches, and it's easier to do when it's out of the unit too. And then after that, I'll put it all back together. I did check caps. Caps are all fine. I'm going to leave them alone. I don't see any problems with caps. I do see one problem though. I'm going to zoom in. Maybe you can see this. two transistors here. These are for the thermal tracking, and they're not even touching the heatsink. So I might just drill a hole in the center of those two transistors and put a plate behind them and bolt them down so that they're in contact with the aluminum heatsink so that they can track properly. Yeah, there's just nothing, airspace between them actually, and that's not right. Alright, so here we are back together. Transformers installed, reused the same power switch, reused the same fuse board. I replaced the European outlets with a blanking plate, and then I cut it for American standard 2-prong, and that fit in pretty nice. These are both switched. I didn't want to put unswitched. I don't know the purpose behind unswitched outlets. I always like to see them switched if possible, but that's just my personal opinion. So blanking plate, everything looks good on the back. 2.2 meg resistor to chassis. That's standard for North American. I think it actually was 3.3 meg in the schematic here, but this is just to drain off any static charges. This little board here had two fuses on it, or two fuse holders on it with one fuse, and you get to choose between 220 volts or 240 volts depending on which tap you selected with the fuse. So I just removed the one fuse holder and used the other, and upgraded the fuse to a 2.5 amp, and used this board. This capacitor is across the switch. I don't know if you can see that in there, and then the wiring for all this. The switch itself, they used, on the European wiring standard, they used two sets of contacts. One set was for one part of the line, and the other was for the other part of the line. So both input lines were switched. So I just paralleled these two switches together, and we're using them both together and using it as one switch. Pretty vanilla. Nothing really. If you went after the Harman Kardon schematic, this is basically what I copied here and built. Power switch, capacitor across it, switched outlet, 2.5 amp fuse, resistor to chassis, and unpolarized plug. I went with an unpolarized plug today. I wanted to make sure everything was insulated properly, so I had heat shrink on everything I could get heat shrink on, except for the fuse is still exposed, but it's down low and it's not going to be touched if you put your hand over it. And then the secondary, I just ran it over to the main board and connected it all up, so it's all ready to go. Just have to do a test now. I don't think there's anything else to tell about this. Mounting holes, used all the same mounting holes, so it all looks original. And yeah, it's converted to 120 volts now. One thing I need to do yet is make a sticker to put over this 220 volt 50-60 hertz. I need to make a sticker for this to let people know that it's been converted to 120 volts and not to plug it into 220. So aside from the power conversion, I've done a few other little things here. I replaced some electrolytics. They were low value audio grade caps, ELNA caps, and they were testing weak, high ESR, so I replaced them with film caps. There's 4 here I did, and then there was 4 capacitors here that I replaced. They were also testing bad, and they were replaced with audio grade. This is the phono stage here, and phono equalizer stage, so that's been done. Everything else is untouched. I added clamps to those 2 transistors to force them up against the heatsink, so they're thermally coupled now. And that's it. Switches and pots cleaned with deoxit, and we're ready to go, I think. I'm going to do a test on it now. Alright, let's do a power test here while I got it on the bench. So I'm feeding it a 1000 hertz tone like usual, 8 ohm load, going with speaker system A, and let's turn it on. know which one is the auxiliary. I do have a power light. What's the auxiliary here? Hang on. Auxiliary is this one. Tape monitor. Okay, we should have volume. Got nothing. No signal. Oh, I guess turn that on would help. There we go. That one always catches me. Okay, let's turn this up and see what we can get for. All right. Clipping is right here. And we got 16.32 volts RMS. Looks like I'm getting a lot of ripple on the power supply caps. They did test low in value. So let me turn this up, let it cook for a while. At full power. Interestingly enough, this amplifier has no bias adjustment and no DC offset adjustment, so it's preset. I don't know how they're setting the bias. I don't have a schematic, I don't have a service manual, so I'm just flying by the seat of my pants here. But it's starting to warm up. I don't even know what the amplifier rating is rated, what the amplifier is rated at, but seems to be working pretty good. We're getting 16 volts RMS out. And I think that is how many watts? $32 watts a channel. I'm going to turn down, and it is heating up fast. This heat sink is getting quite warm. It is just an aluminum plate that's folded up. Looks like about a 2mm plate. This is getting quite warm too. They're about the same temperature. It's not the most efficient amplifier in the world, but it's working pretty good, I think. Let's have a look at square wave. Let's turn this up. Bass, treble, treble boost, treble cut, bass cut, bass boost. Balance. Everything's nice and clean now. I don't see any pots are clean. Let's turn this down. Let's go back to sine wave. One thing I want to look at is higher frequencies. Let's go up to 20 kilohertz. I just want to see the amplitude as I go up in frequency, it stays the same. Starting to drop right around here, 43 kilohertz. It's doing pretty good. That's almost at full power. So a pretty good little amplifier. Okay. Yeah, it's getting quite warm. I don't want to blow it up. Did pretty good. So I'm looking at this tuner power supply, and I'm trying to source a transformer here. This is 9 volts AC coming, 240 volts, or yeah, 235 I measured the other day, coming in, and this is our 9 volts AC right here on these two wires. And I can confirm that just by going here and measuring 8.3 volts, okay, not 9. But then they do a weird voltage doubling thing here with the diodes and the capacitors. And look at this. If I measure this capacitor, this looks like the main filter cap. Come on. Measures over 18 volts. Now why would they do that? I don't understand that. Why would they have a 9 volt 8 point something volt transformer and then double it up to 18 volts? And then they regulate it back down to, let's see here, there's a little transistor. Let me measure this. Measure the collector. And it comes back down to 13.4. Here's the, I think that's the emitter I just measured, 14 volts in the emitter. No, 14 volts in the collector, sorry. And the emitter was 13 point something. Base. Oh no, this is the collector, sorry. I'm all screwed up here. That transistor, resistor there. Okay. So I could measure the current, how much current we're drawing through this resistor, because this one is in series with the collector. So let's see how much current we're drawing. 477 millivolts. And what is that? That looks like a, I'm going to shut this off. See if I can get in here with a measurement for you. Can you see that? No, you can't. So that's a 4.7, and we got 477 millivolts. What is that? 100 milliamps? I think that's 100 milliamps. Yeah, just 101 milliamps. So essentially what I need here is well, hang on, we got two problems. One problem is the lamp is using the 8 volts AC. Okay, that's not a big deal because we can change this. I was planning on changing this to an LED anyway. 18 volts at 100 milliamps. That's 1.8 watts. So I just need to build a little power supply that's going to supply me with 18 volts at 100 milliamps. And I could use any transformer. I could actually use a 12 volt transformer and rectify that and supply this board with, let's see here, times 1.414 minus 1.4 equals. So I could supply this with a 16 volt power supply from a 12 volt transformer. The regulator will drop it down to 14 volts. That's needed for the circuitry. 100 milliamps, that should be no problem. Okay, so I'll find a 12 volt. I do have 12 volt transformers, so I'll find one and install it. And then we'll rework the power supply to work. Alright, so here's the tuner after a little bit of work. Replace the power cord, North American standard, 2-prong. This is unpolarized because there's no need for a polarized plug with this transformer. Both leads come in, they both tie off to the input leads of the transformer. There's no switch, no fuse. That's the way it was before. The cord came straight to the transformer. This is a 12 volt 500 milliamp transformer. I don't know what volt amp rating is, probably about 10 or 15, but that's ample size enough. I measured the current for the tuner. It draws about 100 milliamps on the secondary, so it's not that bad. I reused the old switchboard, switch, and fuse. I just removed the secondary fuse, the one, because there was 2 tap wires coming off, one for 240 volts, one for 220. So we're not going to be using those 2 taps anymore. We're just using the one. So I removed the second fuse holder, just so there's no confusion as to what plug it into. Use the same 500 milliamp fuse, and the switch is all the same. It goes to the board. Down here I removed the 2 capacitors and 2 diodes that was forming the voltage doubler. These are 470 at 16, and there was 2 of them. And there's no more voltage doubler here. It is a straight bridge rectifier, and I actually replaced this capacitor too. This was a 470 at 25 volts, and I replaced it with 1000, just because I removed the voltage doubler caps, and we got less filtration with those caps removed. So I doubled this capacitance. I measured the voltages before and after the transformer swap, and everything remains the same. This filter cap still has 18 volts on it, 18.5 volts. The transistor still has the same voltage drop. It drops from about 18.5 down to 14 or so volts. So we got about 4.5, 5 volt voltage drop at about 100 milliamps. So this transistor is regulating and dissipating about 400 or 500 milliwatts. It does get warm to the touch. You can put your finger on it though, so it's not that bad. Aside from that, everything remained unchanged, and it's all the same. Now, we still have to deal with the problems of this tuner, and I did find a schematic for this. It's not a very good one, but we have, sorry, let me close that. This is the HA-1138. This is the AM receiver chip, and it has about 15 components around, support components. Now this is the one that breaks into oscillation when we were tuning at the low end of the band on the medium wave. So I was looking at the circuit trying to figure out what's going on with that, and I've come to the conclusion it can only be one of a few things. It could be one of these capacitors has gone out of tolerance and opened, and it's providing less filtration on the power supply. So I looked, I don't know if you can see this very good. This is not a good printout. This essentially is the whole AM radio right here on this one chip. Here's the tuning for it and the band switching. There's 2 bands, medium wave, long wave, and there is one capacitor here off of pin 7 that goes to ground. It's a 10 microfarad, and there's another capacitor, where is it, off pin 14 that also goes to ground. That's a 47. So I'm going to check these 2 capacitors, and then if those capacitors are okay and we still have the oscillation, I'm going to assume that there's something, maybe we're getting dirty power. So I might have to scope the power input here. I don't know exactly which. I have to figure out which one of these pins is your power feed. But we're going to scope that to see if that's the cause of the oscillation. All right, so let me pull those 2 caps and test them. Okay, so what I did is I removed this cap and tested them. They're fine. Actually, they're actually better than the ones I would have replaced them with for ESR, and so they're pretty good. But then also I noticed there was one on the back. This one tested bad in that it was 47 at, no, it was actually 33 at 16 volts, and it tested down around 28, 26 or something, and it had a high ESR. So I replaced it with a 47 at 16. A little more capacitance. This capacitor here is sitting on the power supply. I didn't realize this till after, but let me zoom in and you can have a look. Okay, so that capacitor I replaced is sitting right here, and this choke and this capacitor form a filter network for this chip. So I'm wondering if I have, let's see here, this comes from, where does it come from? I don't know, it doesn't matter anyway. But I'm assuming this is the power feed, because usually you see a coil and capacitor together like that. That's to filter out any noise or hash in the power supply. So I go out and let's scope the power going in. I got my scope running, so let me get the scope connected. Okay, let me swing the camera around. Alright, so that's the power going into that amplifier, or that AM chip. Let me tune down. You see it starts to oscillate. That thing is rock solid. There's no problem with that power feed. So what is going on here? When I tune it down, it starts oscillating. I'm beginning to think it might be a bad connection to the switch. Let me see if I can. Yeah.
$1,000. So now is a very, very good time
when I release it,
to get involved.
It doesn't pick up as well.
780-407 kids 186
when I hold it in. I think that switch is bad. So let's clean that switch, and hopefully the problem's gone. So let's get rid of this. The switch does not look, there's no way to spray it in. You can see the switch itself, it's all encapsulated in black plastic. You can't see it because I don't have light on it. Okay, there we go, maybe. So I might have to just remove that switch, which isn't hard. Just pull off the front panel and let's see here. Yeah, it should be alright to do. I can do that. So let's pull that switch out, clean it. It's definitely buggered.
Families who end up there would get the comforts of home. Find programs like Pet there for a
medium long wave. Works normal. Okay. Alrighty. Let's. I got these switches out, and I cleaned this one. This one was pretty. Well, we'll see. I'll show you what the other one looks like inside. There's no way to spray D5 into these. There's no holes. Everything's sealed off. That is not a way in. That's the latching mechanism. So, yeah, the only way to get these properly cleaned is to disassemble them. And I'm going to show you how it's done right here, right now. Just to get it off the rack. So, I was kind of surprised. I think there's some corrosion going on inside these too, even though they're flooded with some kind of a grease. Everything looks wet with something. So let's get this out. Kind of wiggle it out. I didn't get these straight enough. Okay, first thing is to pull back on the spring and pull this clip off. Okay, put that aside, get rid of the spring. Now, you see, look, it's all wet with something. Somebody sprayed something in there. The secret is you got to pry the back apart first. There's a little thing sticking up here, and it's through the plastic and it's holding. So just get a small screwdriver, wedge it in here, and just pop the top off at the back, and then the whole top will come off. The plunger stays with the contacts, and there it is. There's your latching mechanism on top. That's why I don't think spraying in there is a good idea, because it's just going to land on top of the thing here, on top of the plunger. So this can get lifted off, and see all this green stuff? Green and brown. It's all different colors. Let's take this apart. Whatever you do, don't lose these. 6 of them. Now we need to clean this somehow. It's got something on there. I don't know what it is. I don't think it's a grease. Maybe it is a grease. But why is it brown? This is just this is it's kind of a, I don't know, it's kind of like a solvent. It's got a weird smell to it too. It's not like your regular contact cleaner. I want to try this stuff too. This is neutral. Let's see how this works. That's not too bad. I get the feeling almost like somebody spilt something on these switches. But they're too far back in the chassis to get splashed if anybody spilt on the front. That's why I think somebody sprayed something in here that doesn't agree with it. Anyways, we'll get it cleaned up. Put these in a pile. And give them a blast. All right, now for the important part. This part here, all the contacts, they don't look bad. We're going to clean them anyway. I just give them a good shot of this. This switch isn't as bad as the other one I took apart. The other one had corrosion in it. This one seems a little better. So I'm kind of wondering how it would get corrosion inside. Okay, it's starting to come clean now. Okay, I think that's good. Dry this off. All our contacts are good. Okay, so now we need to start reassembling these. There's not much you can do with them. If you really wanted to, you could put it on the edge of a paper towel and clean it. But you don't. These are fragile. You don't want to bend these at all. Okay, next we need to do some lubrication because we're going to start reassembling. So I'm just going to put some grease on the sliding surface. Just a little bit. Okay. Give it a bit more on the outside here too. All right. Now we can populate these with this contacts. See, how come I got 5 now? Where did the other one go? You gotta really keep your eye on these because they disappear on you. It's got lint on it. And if any of these are damaged or bent, you're going to have to try and straighten them out because you don't have, unless you get another switch identical you can rob parts from, these aren't going to, you're not going to find these pieces anywhere. Okay, so just line them up. Nope, goes here. Okay, perfect. Now we do the deox treatment. I'm only applying to the outside, but you're going to have to hope it flows through to the inside. And just give it a good workout. I suppose you could apply it to the inside too. Why not? I don't want to get too much on there. Okay. The top slides on these two posts here and makes contact to us. So we're going to grease those parts. Give it a little bit of grease to keep it and just press it back on. Line it up. Spring. And the clip. Might have to reform this clip. Just as brass. You got to be careful with it. It's soft. I don't think it's on though. Voila! Cleaned and deoxed. Now that should work like a brand new switch. If you want, get your ohm meter out, test contacts. This has one. Okay, you could probably buy these. I just never seen them with the. What's it got? 9 contacts on each side. I've seen the 6 and 12s. I haven't seen the 18s. All right, I'll put that back. I'll do this one, and then I'll put it all back together. All right, just a quick check to see how the AM tuner is doing after I clean the switches, put everything back together. Let's turn this on.
Yeah, but I think that again, it's this question of who can win the membership and when.
For sales, service, parts.
Actually, the AM's working pretty good now. I don't know what it's picking up here at, where are we at here? We're about 500 kilohertz. But it's not oscillating anymore. This buzzing noise though is horrible. I don't know what would be causing that. I don't think I have everything on the bench that would cause that.
Voices as compared to
Getting good sensitivity and good selectivity. It's gone. Once I go up around 1.6 megahertz, it stops. It's got to be interference.
they are the ones that are holding the majority of support in party right now.
Okay, so let's check out FM here. And we'll see how that is doing. Got a single wire antenna hooked up, so. I think it probably needs some help here because it's barely picking up anything.
Contractors can make $109. We're making money at that price? Gosh, I keep forgetting to do that.
Michael, this is a magical pendant.
Still not getting any stereo. try on the top end of the band here. Yeah, there's no stereo at all. Okay, so we still have work to do to the tuner. I'm gonna get this FM all dialed in. Just want to check the bulb for the stereo lamp, and I think it goes pin, it's not really marked very well on the board, 6 and 7. And that kind of coincides with the schematic 8 volt 50 milliamp bulb. And when I check it, let's see if I can check this. Yeah, it's showing like 20 mega ohms, so it's open. Yeah, so let's replace that bulb. I still don't think the stereo is happening though. I don't hear any separation yet, so let's replace that bulb and then we'll try it out again. Alright, so I'll show you a little bit of what I did here. First thing I did is I replaced the bulb. Yeah, it was burned out. Now it's working, and I am picking up stereo stations. The bulb does light up when I lock in on a stereo beacon. I did a little bit of alignment on this. FM was pretty poor condition, so what I did is, first thing I did is I tried to align the dial scale to my signal generator. When I first tested it, it was about 1 megahertz out. So for example, if I was at 100 megahertz on the dial, I was picking up stations at 101. So it was that far out. And there is no, typically, in FM receivers, typically there's 2 adjustments. One for the low end of the band and one for the high end of the band. And on the RF oscillator, they have 2 adjustments. One of them is the coil itself. And you can see the coil here. It's peeking right through here. How you adjust that coil is you open up the windings or close them together, depending on if you want the frequency to go up or down. And that's how you adjust the frequency of the coil, of the oscillator. That's for the low end of the band. And for the high end of the band, typically they have a trimmer capacitor, but it's missing here. And what they did is they installed a trimmer capacitor under here. I don't know if you can see it. It's a little trimmer capacitor. So I could go in and I can adjust the trimmer capacitor just fine. I can put my signal generator on 100 megahertz, and I can set the tuning dial to 100 megahertz, and I can go in here and I can adjust the capacitor, and it would lock and it would align. Problem is, when I went down to the bottom end of the band, 88 megahertz, the tuning dial was off by 1 megahertz. So in order to fix that, what I had to do is, I don't know if you can see this. This tuning coil I can't change. I tried jamming a screwdriver in there and it's completely epoxied together. It looks like it's just 3 wraps of wire, and it's solid. You can't spread those coil windings apart. What you have to do is you have to go down here. This is the capacitor for the local oscillator, and I had to spread these 2 plates apart to kind of give this lower capacitance, so that when I went to the low end of the band, when I fed an 88 megahertz signal, it would tune to 88 megahertz. So I went back and forth and I adjusted this a number of times so that when I went to the bottom of the band, it was right. Then you go to the top of the band and you can see the plates have less influence because they're being removed. And then you go to the top of the band, and I did this again at 108 megahertz. I was actually 1 megahertz out. I was tuning in 107. And then you go and tune the capacitor. That's what the capacitor is for, is the top end of the band. So adjust the plates for the bottom end of the band when the capacitor is closed and it's at maximum capacitance. And when the capacitor is open and it's at minimum capacitance, you adjust the trimmer for getting the band accuracy. That worked. And then I went on to adjusting these two trimmers here. These two trimmers here are, let's see here, I don't know if you can see this on the page. So here's our little oscillator circuit, the coil, the tuning capacitor, and the trimmer capacitor. And then there's a fixed capacitor. And that's what I was adjusting. I was adjusting these two caps. And there's also a trimmer capacitor up here. This is the input. This is antenna matching. So antenna matching and end stage matching. So what I did is I went up here and adjusted these two capacitors for maximum output on a low level signal. I turned the signal generator down to almost nothing and then adjusted these so that the signal came in the strongest. And then that was it. That's all there is to do. And actually, the receiver really works good now. It works a lot better than it did. Let's go have a look at the dial. Alright, starting at the low end of the band, I'm going to work my way up to the scale, and we're going to see how this thing picks up stations now. It's going to be a lot better. It's got no problem picking up stereo now. And the muting's working properly. Another thing I did is I adjusted the local oscillator on the phase lock loop for the demodulator to 19 kilohertz. It was up around 300, I think. It was about 300 kilohertz or 300 hertz out. So I adjusted it down, and it locks in a lot better now. Has no problem picking up stereo. And it's got a lot more sensitivity and selectivity now that I did the adjustments. So this tuner is working good.
The same year that
Picking up all the stations.
Her goal is to be adopted. The piece in your backyard.
That last one there is our local station. It's the strongest.
Why not call Gibbons?
There's no strength meter, it's a center tuning meter. So you gotta
We are North Central Co-op and been proud
hit the needle to the middle to get it centered.
communities since 19.
But it's working good. It's picking everything up. So that's it for this one. I'm going to get this back to the owner. I think he's going to be happy with the voltage conversion and the repairs I did. So that's it for this one. Also, with these two items, the two Pioneer components that were running on 220, he also brought me a turntable, a Pioneer turntable. No, it wasn't Pioneer, is it? Yeah, I think it is. And that is also on 220 volts. And he asked if I could do a conversion. But sadly, I can't because the motor is a synchronous motor, and I can't change the frequency of a synchronous motor to work. Plus, the voltage is off too. And he also brought me a cassette deck. And the cassette deck was wired for 220. It's multi-voltage. So that one's going to come up next. I'm going to tackle that one after this. So that's it for this one. Pioneer's done. I just want to mention also that the amplifier sounds great. I'm using it right now on my desk, and I've been listening to it for about 4 days, and it's got a really nice crisp, clean sound. It sounds pretty good. I'm impressed with that little amplifier, with what it is. So these two will go good together. I'll put them back, and we'll see you on the next one. Thanks for watching.